This is the second portion of the Chapter 4 test review, and now we're only going to cover the second portion of your test, which was the free response section, not the multiple choice. Okay, so let's look at this. We're going to factor this expression. Well, first, let's try to reduce it. Let's factor out what we can. And when we reduce it, we notice that 7 times 4 makes 28, and 7 plus 4 can be 3. So you can factor it out. You have a negative 7 and a positive 4, which gives you negative 3. Negative times negative will give you a negative, and so there you go. That's the answer. If you look at number 9 beside it, it asks you to solve for this. You always want to put all your variables on one side of the equation. So I moved everything over to one side, and then I can factor out my u and u plus 3. This would be the same as saying u plus 0 times u plus 3, because the u can factor out of both. So u is equal to 0 and negative 3, because you set them equal to 0. Okay, let's look at number 11. Number 11 says find this 0 by rewriting it. Okay, so you simply take and make it the intercept form. All right, so I factored out a 2x, and then it left an x minus 2. So when you set this equal to 0, you get 0. When you set this equal to 0, you get a 2. And that's simply your answer. Okay, let's look at the next one. 13, ask you to simplify. Everything under the radical can go ahead and go together. Anytime you have a radical times another radical, you can put everything underneath. What I'm looking for is I want to find a square under the radical. Because if I can find a square under the radical, I can simplify it to just be that number. Okay, so here I have a 12 and I have a 6 times 2. So I decide that I like to have a 12 and another 12, because 12 squared can come right out of the radical to be 12. And when I multiply 6 times 12, I simply get 72. So that's the answer to number 13. Let's look at number 14. Number 14 is a beautiful perfect squared. It's actually in the form, if you rewrote it, as a squared minus b squared, because it's 25x squared minus 16, so you could do a plus b. So either way, there's a couple different ways you could do this, but I went ahead and just took the square root of both sides because my variable's on one side and I have a constant on the other. So I went ahead and took the square root, so I get 5x is equal to plus or minus 4, and I simply divide by 5. If you look at number 15, it also has, what I decided to do on 16 was just use the quadratic formula, because there wasn't anything easy that came out of 5, like 1 times 5 is all you can multiply evenly as far as whole numbers, and neither one of that doesn't give you a 3. So I just simply used the quadratic formula, negative b, which negative and negative gives you a positive, plus or minus b squared minus 4 times a times c, all over 2a. When you plug all this in, you will solve it and get the correct answer. There will be 2 answers. Okay, number 16. It asks you to write it in standard form, okay? Well, standard form means that you have a real portion and you have a complex portion. Well, how am I going to rationalize the denominator? This is in the form of a plus bi, so I'm going to multiply it by a minus bi. Whatever I do to the bottom, I also have to do to the top. So on the numerator, you're going to use your FOIL to multiply out. On your denominator, you're going to get an a squared, which is 4, minus b squared, which is minus 25i squared. Be sure that it's a minus 25i squared. Remember that I squared is negative 1, and so you're going to reduce and simplify to get your answer. Okay, let's look at number 17. 17 asks you to find the absolute value. You needed to know that the absolute value is the square root of a squared plus b squared. Here's a, here's b. So a squared is 5 squared, b is negative 12, you square it, you get 144. When you add those up, you get 169. It's handy to go in your calculator to see if there's an actual square root of 169. It happens to be 13. Let's look at number 18. 18 asks you to complete the square. Well, completing the square means that you're going to take b over 2 and square it and add it. So what I did was, here's your b. I divided it by 2 and I squared it. Whatever I do on this side, I also need to either subtract it on this side or add it to the opposite side. It doesn't really matter. So I decided to subtract it. Since I added 81 over 4, I subtracted 81 over 4. Now I need to convert my 9 into the whole number into a fraction which has fourths. So I multiply 9 times 4 is 36, and so I have positive 36 and negative 81, and that gives me a 45, and I went ahead and moved it to the other side of the equation. So I have 45 fourths, and then I have a perfect square. At this point, I square root both sides. So when I square root something squared, I get that thing. And on this side, I get plus or minus whatever this is. Be careful, because there's a way that you can reduce this. So you want to make sure that you reduce it. You're looking for a perfect square in here. And I see a 9 times 5 underneath there. And 9 is something squared. So you want to make sure you bring that out of the radical when you go to do that. Move this 9 halves over here and simplify, and you'll get the correct answer. Let's look at number 19, or 22 rather. Number 22 asks you to find the discriminant and the number and types of solutions. So the discriminant is in the form of b squared minus 4ac. So b is negative 6 minus 4 times a, which is 3, and c, which is 8. So you type those in, and you get 36 minus 96, so it's negative 60. What do we know about the discriminant? The discriminant is the thing that ends up being under the radical when you're doing the quadratic formula. So if I have a negative number under the quadratic, or under the radical, what does that tell me about my solutions? I'm going to end up getting, since it's negative, I'm going to end up getting plus or minus something I. That tells me that there's 2 imaginary solutions since they're under the radical. Let's look at 24. 24 has a quadratic function whose graph has these characteristics. The vertex tells you h and k, so h is negative 3 and k is 0. Point tells you x and y, so here's your x is 0 and y is negative 9. So if you look at this formula, you have y, x, h, and k. The only thing you do not have is a. So if you take all of your numbers and put them in, which I did here, you solve for the letter a, and after you solve for a, you just simply rewrite this equation with the actual a that you solved for, as well as your h and your k. Since k is 0, you wouldn't need to include that to simplify it. Number 25. 25 tells you your x-intercepts. Well, conveniently, you can use this formula, y is equal to a, and then here's your 2 x-intercepts. They give you p and q. Remember, there's a minus here. And they give you x and y, right here. So again, you have everything in this equation except for a. You have every other letter as a number. So you can plug all those numbers in, solve for a, and then go back and rewrite it into the equation. And that's how you do it. Good luck.